Hello, students. Hello. Hello, I'm back. You should be able to hear me now. Good evening, everyone, and especially everyone who is here. Now, today we have a slight change. We're gonna switch to another chapter. I think it's the second part of variations. Now, after talking about the direct variation and the inverse variation, those two, basically, those two are relations between two variables. If you didn't pay attention, now we are always talking about X and Y, A and B. They have direct variation or inverse variation. And starting from today, when we talk about joint variation, and later on you will hear partial variation. Basically, we're discussing three or more variables, their interrelations. Now, talk about joint variation. Take A equal 1/2 times base times height. This is a very well-known formula for calculating the area of triangles. Now, this is an equation involving three variables. And we can say that in this case, variable A varies with the product of two other variables, B and H. And we can, in simple, describe the relation as A varies directly as B times H. And also, we call this relation among A, B, and H a joint variation. We can also say that A varies jointly as B and H. The definition of joint variation is very simple. If a variable varies directly as the product of two or more variables, and then their relation is a joint variation. Please note that a joint variation can involve both direct and inverse variation. For example, this is a formula connecting X, Y, and Z, and Z equals 3 times X divided by Y. This can be also called a joint variation, and where we describe Z varies directly as X, at the same time inversely as Y. So in simple, Z varies directly as X and inversely as Y. Now, because there are so many different ways to talk about the relations amongst three or more variables, so I have a few examples to show you, and hopefully through all these examples, be able to distinguish from the description what kind of relation they have. So look at a quick example. In this example, you're going to write an equation to express the idea of the variation described, and using K as the variation constant. Example 1, X varies jointly as Y and Z squared. In that case, X is on the left, and then on the right, you have Y and Z squared jointly as a product, and then you have the variation constant K. Example 2, P varies directly as Q cubed and inversely as R squared. So P, in this case, equal to Q cube. Instead of multiplying, I'm going to put dividing R squared jointly, and then I'll put the variation constant. That's directly and inversely. So we'll put them together. Example 3. Z varies jointly as y and the square root of x. So z is on the left, y and the square root of x are put together with a variation constant k. Example 4. R varies directly as the product of s and square root t and inversely as v cubed. Now here we have 4 variables. That's r, s, t, and v cubed. So r is on the left. On the right hand side, I have the product of s and t and the square root t, and inversely as v cubed. So I'm going to divide v cubed and then put the variation constant. Last example. Now this example, it's a very long sentence, but you have to understand what they're saying. It says that when u remains a constant, then v varies inversely as this square root w. When w remains a constant, v varies directly as u squared. So it's like describing the relation between v and w and v and u separately. So v and w and v and u. So it looks like there are two relations, but when we put them together, you should be writing a relation connecting v and w and u together. So on the left, you will have v. On the right, you will have a joint, something joined with the square root w and u squared. And that is u squared divided by square root w. And I'll put equal sign and the constant k. Like that. So if you take u out of the equation, if u remains a constant, then when you look at the equation, it means that v varies inversely as the square root of w. And if you take w out of the equation, then you can see that v varies directly as u squared. Is that okay? I'll give you another example. Last lesson, I think Sophia mentioned PV equal nRT, right? PV equal nRT. But this is a very well-known formula. And you can say that if P is a constant, then T varies directly as V. T varies directly as V. If V is a constant, then T varies directly as P. Now, this is when P is a constant. This is when V is constant. I can describe the variation separately. Now, T varies directly as V, T varies directly as P. But when we put them together, I can say T varies jointly with P and V. Or I can say, what is it? T varies directly as P and V. Do you see what I mean? I think you know. So look at the example. Suppose y varies jointly as x and z square root z. When x, y, and z are given, can you express the formula? And it's very simple, I think. So because y varies jointly as x and square root z, therefore I can assume that y equal k times x times square root z. And then I can substitute x equal 2, z equal 4, and y equal 120. I will get 120 equal k times 2 square root 4, and k will equal 30, and therefore the formula can be found. Very straightforward. And then part B, when x equal 19, what z equal 25, it's easy to find y. Can be found. So example 9, the use of the formula. Example 10. It is given that P varies directly as Q and inversely as R. Now, when Q equal 4, R equals 6, P equal 48, express the relation between P and Q and R. This is very similar. It's just this time the inverse variation is involved in this joint variation. So A, because P varies directly as Q and inversely as R, therefore P equal K times Q over R. I can substitute Q equal 4, R equals 6, and P equal 48, and K can be found. Okay, and then part B. When Q equals 7, R equals 3, I think we can find P directly. Okay. It's very refreshing for us to touch on these topics. Moving on. Example 11. The example is 11. We're talking about it's another example of showcasing how to find percentage change. Now you can observe that in the previous lessons before the discussion of the percentage change, we have for each variation we had one example of plotting graph, right? We had plotting graph of direct variation and inverse variation, but we do not plot graph for joint variation, and I think you can know why. Is that usually we do not plot graph for 3 or more variables, so in this case there is no graph. There's no graph. I think in a way it's better that way, because with graph it's very tricky. So for the percentage change, we're going to use exactly the same method. So because x varies directly as the square root of y and inversely as z, maybe I put them together, square root y and inversely as z. Therefore, I can say that the formula look like this. Okay, now if y increases by 44%, z decreases by 20%. So I have a new y, that's y prime, equal 1 plus 44%. That is 1.44y. The other one is uz z prime equal z times 1 minus 20%. That is 0.8 z And then I will have a new x. In this case, it's k times square root 1.44y divided by 0.8z. And in this case, the calculator. $1.5. Am I wrong? I hope I'm not. What is that 85%? 1.44. That's 1.2. It's not 85, it's 7.5 though. Is it y increases? Oh, square of z, sorry. The square of z. Sorry, I made a mistake. It's the square of z. So this is square and square and square. So square. So square. Oh, no, not square. Oh, sorry. It's the square of z. No. Sorry, I made a mistake. So in this case, it's k. Let me change the color. It's k times 1.2y divided by 0.64 z squared. In that case, it's 1.2064 120 divided by 64, that's 430, 416, 28, 215. Yes, that's 15 over 8k times square root y divided by z squared. Okay. Therefore, the percentage change in x equal 15 over 8 k root y divided by z squared minus k root y divided by z squared divided by k root y divided by z squared times 100%. And this can be reduced to 15 over 8 minus 1 divided by 1 times 100%. And that should be 87.5%. I think. Isn't it? Now I was reading it wrong, huh? And also I think sometimes when you see square root and square, and don't mess them up, huh? It's very different the result if you mess them up. Let's go straight to the classwork. In the classwork, suppose P varies directly as Q and inversely as W. So P varies directly as Q and inversely as W. It's a joint variation. Oh, sorry, there's no K. Why do I do that? In the symbol, you don't write K. You don't write K. In the equation, you write K. Therefore, P equal K times Q over W. Okay. For part A, if P decreases by 5% and W increases by 20%, find the percentage change in Q. Now, in this case, if I want to find the percentage change in Q, I better make Q the subject. So instead of using this formula, I'm going to use this formula. So that's Q equal P times W divided by K. So in that case, the new P equal P minus 5%, 0.95P, and W equal 1 plus 20%, that's 1.2W. And therefore, Q prime, the new Q, equals 0.95P times 1.2W and divided by K. And in this case, 0.95 times 1.2, 0.95 times 1.2 equal 1.14. So this is 1.14 PW divided by K. And therefore, the percentage change in Q can be found 1.1. I think it's easier if I write this. This will be equal 1.14 Q. I think it's easier this way. That's 1.14 Q minus Q divided by Q times 100%. I think it's easier, don't you think? 14%. It's much shorter to write. Copy. Now P increases and Q remains unchanged. Find the percentage change in W. Now, if I want to find percentage in W, I better make W the subject. So in this case, I will write W equal K times Q divided by P. So this is the formula I use. So in this case, P prime prime equal P1 plus 25%, that's 1.25P, and Q remains unchanged. So we do not touch Q. And W prime prime equal W prime prime. That's K times Q, that's unchanged, divided by a different P, which is 1.25P. In this case, 1 over 1.25, 0.8. So this is 0.8 AQ divided by P, and that is 0.8 W. So in this case, the percentage change in W can be found as 0.8 W minus W divided by W times 100%. And that is negative 20%. Let me check the answers. Oh, that's it. That's it. Now, I admit that the classroom is a little bit different, right? But you should be used to that. It's okay to ask for, you have to do a change of subject before you move on to the percentage change procedure. It's understandable. It's understandable. This presentation, I think after we fix this part, it clearly is very brief and concise. I hope you can write this way. I really hope. Even if you use another method, I hope you write very clearly. So that's it. That is the joint variation because we don't have any graphs involved. So it's only 3 examples. Is it fine? Now, before we move on, I want to point out one thing. On this page, on the previous page, page 10, you will see that in a quick example, there are 5 examples of describing a joint variation. And sometimes the word jointly is mentioned. You can see in example 1, jointly is mentioned. In example 2 is not mentioned. In example 3, jointly is mentioned. In example 4, not mentioned. And example 5, obviously, the word joint is not mentioned, but through the description, you must form the understanding that they are talking about a joint variation. That's the only way to understand it. Okay, so sometimes even if the word is not mentioned, you still should assume there is a joint variation. Why? Because there is another one. Now, sometimes when we talk about the relation amongst 3 or more variables, it's not a joint variation, and it's called a partial variation. The definition of partial variation is that variation consists of a sum of 2 or more different parts, and that is called a partial variation. Now, I'll just give you an example. That if one part of Z varies directly as X and one part varies directly as Y, so one part, you will see 2 different things in the formula. And that is one part is a variation of X, one part is variation of Y, and they're not joined together, meaning that there's no X times Y. It's X is one part and Y is one part. It's one part. So this is called a partial variation amongst 3 or more variables. Another example, this is a special case. Now, sometimes Z can be a constant and one part varies directly as X. In that case, we're describing a relation between 2 variables. That is, Z is one part constant and one part varies directly as X. Okay. Basically, if this partial variation, you will see a part and different part and maybe a third part. Note, this partial variation, where we say that Z varies one part partly as X and partly as Y, does not mean Z varies directly as X plus Y, because in the formula you cannot see X plus Y. Do you know what I mean? Partly doesn't mean some. It does mean some. It does not mean X plus Y the sum. It means something times X plus something times Y. That is a sum, but not directly as X plus Y. Anyway, you will see what I mean. Now, a very similar quick example. That write an equation to express each of the following variations with K1 and K2 as the variation constants. Let's read it. So Y is partly a constant and partly varies directly as X squared. In this case, you will write Y is partly a constant and partly directly as X squared. So a sum. Number 2, one part of M is a constant and the other part varies inversely as N. So one part is constant and one part is inversely as N. Example 3. Y is the sum of 2 parts. One part varies directly as X squared and the other part varies directly as Z. So Y directly as X squared, the other part directly as Z. Number 4, Y partly varies directly as X and partly varies inversely as Z. So Y partly and partly. Number 5, R partly varies inversely as P and partly varies directly as square root of Q. So R partly varies inversely as P and partly varies directly as square root of Q. Do you know what I mean? I think it's very, if you follow the language, I think it's very easy to write the equation now. As long as you don't think there is a multiplication involved. When I say partly P and partly Q, I don't mean P times Q. Okay, I mean one part is P, one part is Q. They're separate. Is it fine? There's a quick example before we move on to the examples, to the official examples from the textbook, is that sometimes there's just one case. Sometimes the graph is involved when you see a relation between X and Y, and this is Y and this is X. When you see a relation between X and Y, and then this is an easy relation because we learned this before. It's a linear relation. Y is a linear function of X. That is back then when we were studying the concept of function. But now if we're talking about variation, now we can use a variation to describe the relation. So what is the variation involved if you see a graph like this? Now, because from the graph, now I'll just go directly with an answer. So from the graph, because you know already that this will imply there is a formula that is y equal mx plus b. So I guess it's natural to say that y, that is equivalent to say that y varies. Sorry, not varies. Y is partly a constant. In this case, it's b, the constant is b, and partly varies directly as X. It's not very common to say that because it's easy to just write out the equation, but there are times you can see this kind of description in some textbooks and even in some other literature that you read, not necessarily from math. And when you say that, when you hear about, oh, y is, or any other variable, maybe a is partly a constant, partly varies something as something else, they're basically describing a linear relation. I hope that's clear. Example 12. So y is partly a constant and partly varies inversely as x cubed. And we have two sets of values, and that will provide enough information for us to find the constants. So because y is partly a constant, partly varies inversely as x cubed. Sorry, going to write. Okay. And then, of course, you're going to find K1 and K2, and it's going to be simultaneous equations. And then the way I handle it, I just want to train you to be systematic and then to reduce the careless mistakes. So one thing I require in all your homework, if you're ever going to do homework, is that you line up with all your equations. That is from the first equation, you do that. And then when you do substitution, that is 31 equal K1 plus K2. And the second equation is 5 equal K1 plus K2 over 27. Now, I sincerely hope that you would follow this so that they'll all line up. And then I think that some of you will proceed to use the calculator. If you're using the calculator, make sure you'll formulas are set up correctly, you remember how to use it, because every calculator is different. If you want to solve it correctly, I will hope that you will write them like this. And then you will multiply 27. Or don't, sorry. In this case, you really don't have to. You will just do the subtraction. This is 26 equals 0 plus 26 over 27 K2. Therefore, K2 equal 27 and K1 equal 4. And then don't forget to write the equation. Okay. And part B, when x equal -2, I think I mentioned that you have to write when x equal -2, back at school. Y equal 4 plus 27 divided by -2 cubed, and that is 5/8. Okay. If you write neatly, it will be done. Example 13. R partly varies directly as S and partly varies inversely as T squared. So I know that R partly directly as S and partly varies inversely as T squared. And I've got two sets of values, so I'm going to write them. That is, the first one is 24 equal K1 times S. That's 3K1 plus K2 divided by 4. The second equation is 24 equal S equal 4 K1 plus this one is K2 divided by 9. Okay, make sure that line up. That's all I asked. Then right now you're going to do elimination. And when you do elimination, you do not subtract immediately because that will not eliminate anything. What you should do is to multiply 4 for the first equation and multiply 9 for the second equation. To multiply 4, that's 96 equal 12 K1 plus K2 plus 9. Okay, and then you will do the subtraction right here. I do the subtraction this way. I don't know. So K1 equal 5 and K2 equal 96 minus 12 times 5. That is 36. Therefore, R equal 5S plus 36 divided by T squared. Is that okay? If you ever going to solve simultaneous equation correctly, that's my suggestion. Part B. When R equal 9, S equal 1, so 9 equal 5 plus 36 divided by T squared, and 36 divided by T squared equal 4, T squared equal 9, T equal 3 or -3. That's it. Moving on. I think more simultaneous equations coming up. It is given that Q is the sum of two parts. One part varies directly as x, and the other part varies directly as x squared. When x equals 3, Q equals negative 24. When x equals 5, Q equals negative 30. Okay. Q is the sum of two parts. One part varies directly as x, the other part varies directly as x squared. That's good. So negative 24 equal 3k1 plus 9k2. The other one is negative 30 equal 5k1 plus 25k2. Okay, now to solve this simultaneous equation correctly, instead of multiplying, I'm going to divide each equation. The first one dividing 3, that's negative 8 equal k1 plus 3k2. The second one, I'll divide 5. I have negative 6 equal k1 plus 5k2. And then I can easily do the elimination. This minus this, that's negative 2 equal 0 plus negative 2k2. So k2 equal 1. That's good. And k1 equal negative 8 minus 3. That's negative 11. Therefore, I have q equal negative 11x plus x squared. In your exam or any tests, if you get k1 and k2 as a very weird number, it's highly likely you're doing it wrong, because you can see all the examples. We have like pretty simple k1 and k2, right? All I'm saying is that be skeptical. Part B. Find the value of x. Negative 10. Sorry, when x equal. Oh, sorry. What did I say? Oh, when q equal negative 10. That is negative 10 equal negative x, negative 11x plus x squared. X squared minus 11x plus 10 equals 0. And x equal 1 or 10. That's it. Like I said, there is not much not much to learn, right? Again, just like last time, we have to go back to the quick example and then really learn how to identify this kind of variation. And when you see the 5 examples presented there, that the keyword, partly. The partly, this word comes up a lot. You see, partly, and partly, part, not just partly, a part, one part, other part, partly. See? That should tell you it's a partial variation. I should also mention that the symbol, the variation symbol, the symbol cannot be used to describe partial variation, because it's one part, the other part. I don't see we use this symbol too much in this one. We don't use it anymore. Difficult to use the symbol. So that's it. That's it. To summarize, it's if the word jointly is used or is not used, joint variation anyway. If the word partly is used, then it's a partial variation. Definitely partial variation. Do you have any question? No, we're sailing through. Huh? We're sailing through. Now look at the application. It's the last part of this chapter. Huh? In real life, how can this be applied? Most of the examples are easy. It's just the last one, maybe. Maybe the last one I need to say something. We just read it and then we'll solve it. The first one, example 15, John conducts an experiment twice. In each experiment, the number of cells N of a certain virus varies directly as the cube of the temperature T Celsius, degrees Celsius. John conducts the first experiment at 16 degrees Celsius and the second experiment at 24 degrees Celsius. What is the percentage increase in the number of cells in the second experiment? Now, first, I want to write a formula between N and T. Because N varies directly as the cube of T, therefore I can say N equal K times T cubed. Write the formula. Okay. Now we can say the first experiment, the number of cells, the first experiment, the number of cells is 16 cube K. The second experiment, the number of cells is 24 cube K. Now, although we don't have enough knowledge to find K, I think it's enough to find the percentage increase. Therefore, the percentage increase in N equal 24 cube K, 16 cube K, divided by 16 cube K times 100%. And that should give you the number. The number is very large, still believable, right? It's 237.5%. It increases a lot. And that's it. I hope that's okay. Huh? I think it is okay. Example 60. The maximum number of clothes, P, that our washing machine can wash in a year varies inversely as the number of years N for which it has been used. If you need to read it twice, it's okay. Huh? The number of clothes P varies inversely as the number of years for which it's being used. It is given that after the machine has been used for 3 years, it can wash at most 60,000 clothes in the following year. Yeah. So express P in terms of N. A. Because P varies inversely as N, therefore P equal K divided by N. And we can substitute 3 and 60 inside. And we will get 60,000 equal K divided by 3. K equal 180,000. And we find the formula. Shouldn't be hard. Part B, if the machine has been used for 5 years, what is the maximum number that can be washed next year? So when N equal 5, P equal 180,000 divided by 5, and that is 36,000. Then you will answer the maximum number of clothes it can wash is 36,000 after 5 years of use. Part C. If the machine can wash at most 20,000 clothes a year, how many years has been used? So when P equal 20,000, 20,000 equal 180,000 and N equal 9. Therefore, it has been used for 9 years. Is that okay? Let's move on. No, move on. 17. 17, I think we're facing a joint variation, I hope. Yes, joint variation. The value C dollars of a certain kind of wine varies jointly as the volume and the square root of the age. I don't think this is reality, but anyway, that is what the assumption is. If V equal 4, N equal 4, then the value of wine is $1,600. And express C in terms of V and N. Now this word jointly is mentioned. And like I said, if it's not mentioned still, you should assume it's jointly. So A. So because C varies jointly as the volume and the square root of N years, therefore you can see C equal K V root N. Right? And N equal 4, 1600 equal K, 4, 4. No. Okay. So K equal 200, and then the formula is found. And then the value can be found. When V equals 6, N equal 9, C equal 200, 6 root 9, that is 3,600. And then the value is 3,600 when V equals 6 and N equal 9. Now in this case, do not write a unit there in the formula. The formula should have no unit at all. Okay. Example 18. Example 18, and I'm hoping that we have a partial variation. I think we do. The monthly salary of a worker in an electronic factory is divided into 2 parts, and one part is a constant, the other part varies directly as the number of devices produced. The monthly salary is $8,000 when 1,000 devices are produced, and monthly salary is $10,000 when 5,000 devices are produced. Can we express the value? Can we express W in terms of M? So A, when W is a constant, and another one is directly as the number of devices produced, that is K2 times M. And then we have 2 sets of numbers, 8,000 equal K1 plus 1,000 K2. The other one is 10,000 equal K1. plus 5,000 K2. And then you will get negative 2,000 equals 0 minus 4,000 K2. K2 equal 1 over 2. K1 equal 8,000 minus 1,000 times 1 over 2. That is 7,500. Therefore, the wage monthly salary equals 7,500 plus 1 over 2 times n. Okay. Now, if the monthly salary cannot be less than 12,000, what is the minimum number of devices produced? Now, in this case, because the word less cannot be less than is mentioned, I prefer that you can solve this by using an inequality. I hope that's fine. I hope that's fine. So when 7 plus 1 over 2n cannot be less than, that means bigger than or equal to 12,000, and that can be solved. Now I think I need to emphasize this though, that because some of you prefer the equation. Is the equation wrong? I don't think so, but it's just less explanation to do if you use inequality. So you use inequality. That's definitely 405,000, and n is bigger than or equal to 9,000. Okay, and then you will say, oh, the minimum number of devices produced is 9,000. Let me repeat. I sincerely hope that you use inequality. I hope that if you use the equation, the marks won't be deducted, but I cannot guarantee unless you explain perfectly fine. I think there is something to say about it if you use an equation. You have to say something and to make sure this is the minimum when you use an equation. But with an inequality, you really can see that from the inequality, because n is greater than or equal to 9,000, you can see the minimum is 9,000. But when you have n is equal to 9,000, you must really explain why isn't 8,000. You know what I mean? Moving on. The last one you have to pay attention to, this one. I think that you will see something new. You will learn something new. Example 19. After t seconds, at t seconds after a paper plane is thrown, the height of the paper plane above its starting position is h cm, and it is given that h partly varies directly as t and partly varies directly as the square root of t. This is a routine partial variation problem. So A, h partly directly as t, partly as the square root of t. And we can find it. So 12 equal k1 plus k2. The other one is 24 equal the square of t, not the square root of t, the square of t. K1 plus 9k2. Okay. I hope I'm not wrong. Sorry, I am wrong. It's 3. I am wrong. So I need to reduce the equation so I can eliminate. If I can reduce, I will not multiply. I will reduce. So 4 equal 0 minus 2k2. K2 equal -2. K1 equal 40. Therefore, H equal 14t minus 2t squared. I think it's correct. Yes, correct. Part B, when H is greater than 24, find the range of values of t. That is very direct. It's almost like the inequality is set up for you. When H is greater than 24. H is greater than 24, that means 14t minus 2t squared is greater than 24. That means -2t squared plus 14t minus 24 is greater than 0. In that case, I sincerely hope that you reduce the inequality. You reduce the coefficients to t squared minus 7t plus 12 is smaller than 0. And pay attention, there is a change of sign. There is a change of sign. And then you can use the factorization. T minus 3 times t minus 4 is smaller than 0. Do not assume that you're solving linear inequality. With the quadratic inequality, you should assume that the answer is more difficult than the formula 0, 1. It's 3 and 4. And then you should take the bottom part because I'm looking for smaller than 0. And that is why your answer is t is smaller than 4 and greater than 3. That is the required range. And I guess the first lesson to learn is not to use formula 0, 1 for inequality. Please don't do that. Please don't do that. Just solve quadratic inequality correctly. If you don't remember, you should. Is that okay? Moving on, the last question. The last question reads very strange. Let's read it. It says that, can the height of the paper plane above its starting position exceed 25 cm? Explain your answer. Can the height, blah, 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 exceed 25 cm? Can it exceed? Can the height exceed 25 cm? It looks like that it's suggesting h as the height. H is bigger than 25 cm. So the question is, can h exceed 25 cm? Now, if we compare this question to part B, the part B is h is bigger than 24. Right? H is bigger than 24. When is that? When is that? And then you found out after calculation for part B that when is that? Oh, after a few steps, you get, oh, when t is greater than 3 and smaller than 4. Between 3 and 4. That's time, right? T is from 3 and 4. That is when h is greater than 24. But this last question is, can h greater than 25? If you think this is an inequality to solve, then you're wrong. Because it doesn't say h is greater than 25. In fact, when you write h is greater than 25, you're suggesting that h is greater than 25. That's an affirmative answer, but the answer is open. It's a yes or no question. In fact, it's leave to you to answer, oh, yes or no. So your answer may be yes or no, you know what I mean? So by saying that h is greater than 25, if you set up this inequality, it doesn't make much sense to set up inequality. Do you know what I mean? So all I suggest is that if it's an yes or no question, can it exceed? You should just back down and say, or maybe it can, maybe it cannot. So you have to do investigation. So to do investigation, you do not set up the inequality. So you will scratch the inequality and go back to this formula and find out something more about this formula. Now this is h equal 14t minus 2t squared. It can be changed gradually. It can be changed further. And then it can be changed, I think at this point, drastically. And then eventually until you reach this point. You see, instead of set up to say that h is greater than 25, you just don't say it. You don't say, oh, h is greater than 25 or smaller than 25. Don't say it. And then you just try to find out. The way you find out is to manipulate the equation, the formula you got from part A, and slowly to reveal the range of h in the end. And through that, you can either plot a graph. I think you can plot a graph now, right? You can plot a graph now. This is h, this is t. And here you will have 3.5 and 24.5. You can plot a graph. And even without a graph, you should be able to say that the maximum of h is 24.5, which is smaller than 25. And then you say, no, it's not possible. That seems more logical. I think, in my opinion, seems more logical than setting up inequality. Like especially when part B and part C are put together, and you should see when the inequality should be used and when it shouldn't. Isn't it? And inequality is used to answer a question like, when will h be bigger than 24? Like when? We already know that sometimes it's bigger than 24. We just want to find out when. And that is when you use inequality. This method, I don't know what you call this method. I think you have a name for it. But in general, this is to find the range of h. It's not to solve inequality, it's to find the range of h. When this method is used, we don't know yes or no h is greater than 25. We don't know. So I just want you to be aware that sometimes you need to find the range of something if a formula is given. And you are well equipped to doing that because you know how to differentiate. That should tell you with the maximum minimum already. There's no question about that. It's easy to find the maximum or minimum even without this method is called completeness square. Even without the completeness square, you'd be able to find maximum minimum anytime. Yeah. So you have a lot of tools in your pocket. Finding any range should not be a problem. You know what I mean? Even if you're not given a quadratic, even if it's a cubic, you should be able to find range. But that being said, I think in our curriculum, it's bounded and it has to be a quadratic. Do you have any more questions?
That's fine.
Yes.
Could I say assume that h can exceed 25 and then I set up an inequality and then I find that h has no solution and then I say no?
I think you will find t has no solution.
Oh yeah.
Yes, but you have to explain a lot. Is it fine? Now, when you set up the inequality and then you get no solution, you must be able to explain what no solution means to you. Is it fine?
How do I explain it? Like,
using words, for example, you set up to say that assume, right? You do not write, for example, you do not write h is bigger than 25. You will add assume that, right? You will say assume that h is bigger than 25, and then you work and work and work. In the end, you find no real solution, right? In the end, you'll find no real solution. And then you will explain that that means our assumption is impossible. Can you say that? After you find there's no solution for t, you can go back to comment on your assumption, and then you can conclude that it's not possible. I think it's fine to do it that way. But like I said, as long as you know what it means.
Okay, thank you.
Thank you for asking. I think that's a lot of, that is potentially a lot of the questions in people's mind. Yes, if you set out to do the inequality, you will find something, and how do you interpret your finding? You must be, now what if you have solution? What does that mean? Right? What if you find a solution? What if you find a ridiculous solution? I think for each case, you have to explain what those means to you. Because the answer may well be possible. What if it's possible, right? And how do you when you solve for t, you must know what each possible outcome, when you solve inequality, when you got one answer, when you get two answers, what do they mean? If you're able to explain that, that's fine. But a very direct way to solve this problem is to find the range of h instead of solving inequality. This is all I'm saying. Okay, you can try inequality if you want. and see if you're able to communicate. I think it's about the communication. The communication. If you use inequality, is it wrong? It's not wrong. It's just you are required to explain a lot. And if you are willing to explain, I think I encourage that as well. Any more questions? I'm going to let you go. So bye-bye.
Bye, Miss Chen.
Bye.